Hello everyone, welcome back to our Python programming course. Congratulations on completing the for loop chapter. So, till now, we have learned how to repeat tasks using for loops, created multiplication tables, solved mathematical problems, and even built pattern printing programs. But today, we are going to learn another powerful looping concept in Python, which is the while loop. Okay, so let me ask you a question. So, imagine you are logging into your Instagram account. If you type the wrong password, does Instagram give up immediately? No, it keeps asking you to enter the password again and again until it's correct. Okay, so now let's think about an ATM too. So if you enter the wrong pin, the ATM asks you again. Also, online games keep running until you lose. Music player keeps playing songs until you stop them. So what is common in all situations? So in all of these situations, we do not know beforehand how many times an action will be repeated. That's exactly where while loop is used. So by the end of today's class, we will know when to use while loop instead of a for loop, and you will build several practical programs using it. So before moving on, let's do a quick revision of the topics that we have learned before, so it will just sum up everything. So which loop have we learned so far? It's the for loop. Okay, so uh, when do we use for loop? So when do we use for loop? Question mark. So the answer should be when we know how many times something should repeat, when we know that the iterations are fixed. Okay, so when number of repetitions are known. Okay, so that's correct. Okay, so now let's say you want to print numbers from 1 to 10. We already know there are exactly 10 numbers, so for loop is perfect. But if you're asking the user for password, will they enter it correctly on the first attempt? Maybe, maybe not. We don't know. That's why we need another loop, which is the while loop. While loop. So our first topic would be what is while loop. Okay, so let me show it to you that while loop first checks the condition. Checks condition. Okay, it first checks the condition, then it checks if it is true or not. If it's true, then it will run the code. Oh, excuse me. If it's true, then it will run the code. Then it will check again. Okay, so it works like this. It checks if it is true for one time, then again it will check it, and then if it is again true, it will check again. Okay, check the code again. And if it is true, then it will run again. So I hope you are clear with it. If it is true, then it will run again until it is false. Okay, so run again. Then it will again check. Okay, check again, and then if it is false, then it will stop. Okay, so check again, false is false, then it will. Okay, I hope you are clear with it. So a while loop keeps executing a block of code as long as the condition is true. The moment the condition becomes false, Python exits the loop. Okay, so let me give you a real life analogy of filling a water tank. So imagine you are filling a water tank. So what you do? You keep pouring water while the tank isn't full. You keep pouring. As soon as it is full, you stop. So this is exactly how Python behaves. Okay. So another analogy is let's say battery charging. Okay. Suppose your phone battery is at 10%. It keeps charging while the battery is less than 100. Once it reaches 100%, then it won't charge more. Charging stops. That's another example of a while loop. Okay, so let's begin with the syntax of while loop. So for that, we will open our online compiler. Okay, so first let me show you the syntax of while loops. First, let me start with a program of count equals to 1. Then while count is less than equals to 5, till until then we'll print count. Okay, then after that we'll increase it by 1. Count equals to count plus 1, or we can also write count plus equals to 1. Okay, so now let's run the program, and it will print from 1 to 5. Okay, so count 1, here we created a variable with a value 1. So this variable controls the loop. Then Python asks, is the count less than or equal to 5? If yes, then it will print the number and then increment it by 1. Okay, it enters the loop. If yes, then it will enter the loop. If this condition is true, then it will enter the loop. Okay, and then the last line, it is for the incrementation. Okay, so the Python goes back and checks the condition once again, and it will continue to do so until the while condition is false. Okay, So let me show you a dry run for this. Okay. So count, condition, and output. Okay. So when the count value is 1, so it will check if the condition, the what was the condition? So the condition here is count should be less than equals to 5. Okay. So is 1 less than equals to 5? Yes, it is true. So it will give us the output as 1. So now after that it has been incremented. The count has become plus 1. So 1 plus 1 would be 2. So now it will check if 2 is less than equals to 5 or not. If yes, then it will print the output as 2. Then again it will get incremented and it will become 3. So now it will again check it as 3 is less than equals to 5 or not. So like that it will continue until, wait, let me show it to you full only. 4 less than equals to 5. Yes, it is also satisfied. Then it will give 4. Then 5. Then is 5 less than equals to 5? Yes, 5 is equals to 5. So it will be satisfied. Now it becomes 6. So is 6 less than equals to 5? No. So now it will stop before. So 1, 2, 3, 4, 5. This will be the output. Okay. So it stops here. This process is called a dry run. Okay. So every programmer mentally dry runs a program before executing it. Okay. So now let's make one mistake. Okay. Let's delete this line where it tells us count plus equals to 1. Okay. We are intentionally doing a mistake so you can learn something. Okay. So now the code becomes like this. And now what do you think will happen? Okay. So let me run it. Now this becomes an infinite loop. The variable never changes. Okay. So the condition that we used here is always true. So Python never exists. Okay, so it keeps on printing and because the while condition is never false now, it keeps on printing. Okay, it is called an infinite loop. Okay, so let me explain it to you with the help of a real life analogy. So imagine a ceiling fan. If nobody turns it off, it keeps rotating forever. Similarly, if the condition becomes false, the while loop never ends. This is called an infinite loop. Okay, so let's do a program or printing numbers. Okay, let me erase this and then write number equals to 1 and then that while number is less than equals to 10. Oh, I've forgotten the colon. Print print number. Then sorry, number plus equals to 1. It is a similar program, okay? So if we run it, it will print number still 10 from 1 to 10, exactly like for loop, but we are manually increasing the value, okay? So now let's try it with another variation. So let's reverse it. Okay, so we start back counting or countdown. Okay, so while count is greater than zero. Okay, print COUN print count minus and minus equals to 1. Then we print last we print, let's say last. Okay, so let me run it. The output will be 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, blast off. Okay, so let me give you a real life analogy. So just wait. Oh, sorry. Okay, so every rocket launch has a countdown. 10, 9, 8, 7. So once it reaches 0, then it launches. This is a perfect use of a while loop. Okay, so let's do another program of a password verification. Let's say mm, this is one of the most practical examples yet. Okay, so let's take a pass as password. Oh, we can't take it is a keyword, key password taken blanks. So while let's see password not equals to, so not equals to is like this, not equals to python 123 password is equal to input password colon. Okay, so then it will give a print message of login successful. Okay, so let me run it. First we'll write wrong passwords. Again. Okay. Till I enter the correct password, it will repeatedly ask me to enter the password. Okay. Now let me write the correct password, which is Python 123. Then it will give me a login successful explain. We never knew how many attempts the user would take. Therefore, a while loop is the best choice. Okay. So let me give you a difference between for loop and while loop, which will make it more clear to you and easier to understand. Okay, let me add a page here and then write the heading as for loop versus while loop. Okay, so here it's for loop, for while loop. for loop, for loop, number of repetition is known. Okay, and for while loop, number of repetition is unknown. Okay, so for loop uses range function and while loop uses a condition. Okay, so for loop variable changes automatically, and for while loop variable is updated manually. Okay, for loop is, I would say, best for counting, while whereas the while loop is it's best for waiting or repeating until something happens. Okay. For loop prints number from 1 to 100, multiplication, tables, pattern printing, while loop is used for login systems, ATM pin verification, menu-driven programs, and games. Okay, so let me give you a practice challenge to you all. So pause the video and solve these problems. Where first question would be to print numbers from, let's say, 20 to 30. Next question would be to print even numbers between 2 and 20 using a while loop. Okay, so let me show you one of them. I will print even numbers using for while loop between 2 and 20. Okay, let me take a variable as num equals to 2. Use while loop while num is less than equals to 20. I would print number. Okay, so now num equals to num plus 2. Okay, so let me run it and see, it will print all the even numbers between 2 and 20. So a homework for you all is to create a program which will print numbers from 100 to 1, print all multiples of 5 up to 100, print the multiplication table of any number using a while loop, and find of numbers from some addition of numbers from 1 to 50 using a while loop. Okay, so excellent work. Today you have learned one of the most useful concepts in Python, which is the while loop. Okay, so we explored how it works, understood the importance of updating the loop variable, learned about the concept of infinite loops, and built practical programs like countdown timers and password verification systems. In the session, in okay, so in the next session, we will learn about three most powerful loop control statements, which are break, continue, and pass. These statements give you a greater control over the loops, how loops behave, and are used extensively in the real world Python application. So, until then, practice every program for today's session, experiment with the different conditions, and don't forget to dry run your code. Thank you for watching. I will see you in the next question. Happy coding. Thank you. Hello everyone, and welcome back to our Python programming course. In the previous session, we learned about the while loop and saw how Python repeats code as long as the condition is true. But here's an interesting question. What if we want to stop a loop before it naturally ends? Okay. And what if we want to skip only, let's say, one iteration? Or what if we are writing code that we will complete later? So Python provides us with three special keywords for these situations: break, continue, and pass. These may look like small keywords, but they are used in almost every real world Python applications. Okay, so before moving on, let's do a quick revision on the topics that we have learned before. Revision. Okay, so let's start with which two loops do we know? Which loops have we studied about until now? So those are the for loop and the while loop. Okay, excellent. So the first question would be, when does a while loop stop? When does a while loop stop? So it stops when condition becomes becomes false. Okay. So while loop stops when the condition becomes false. But today we will learn how to stop or control a loop even before its the condition is false. Okay. So that's where the break statement comes into the scene. Okay. So while a loop is running, sorry, while a loop running, then we want a break. We write break, then the will stop, loop stops immediately. Okay, so the break statement immediately terminates the loop. Python doesn't check the remaining iterations, it exits the loop instantly. Okay, so what happens here, if you want to skip the iterations and go directly to the result after your condition is satisfied, let's say not complete the whole iteration, so you can use the break statement there and it will exit the loop instantly. Okay, so let me give you an example in a online compiler. So let me erase it. So for I in range 1 comma 11 If I equals to let's say 6, then break. And I okay. So let me run this code. So it is printing till 5. Okay. So Python reaches 6 because it checks the condition if 6 or not. I have used the for here, and now when it reaches 6, then it sees break and the loop ends immediately. So let me explain it to you with the help of a real life analogy. So imagine you are reading a book. Your friend calls you urgently. You immediately close the book. You don't finish the remaining pages. So that's exactly what break does. Okay. So now let's solve another problem of a password system. Okay. So let me take a correct password as input. Correct pass equals to Python 123 while it is true, while true password equals to input, enter password. Okay, it enters the password. Now if password equals to the correct password, then it would print as login is full. Then it will break, and then it will sorry break, and it will print from wrong password. Okay, now let's check this program. The password, it's asking me to enter a password. I would enter anything. Sorry. Okay, I've taken here this password. These are some common mistakes that people tend to do. Password is telling me to enter the password again. Again, a wrong password, enter password again. Okay, so without break, this loop would continue forever. Now, if I would ask it to the correct, sorry. Okay, imagine entering your ATM pin. Once the correct pin is ATM is entered, the ATM stop asking again. Okay, that's a break applied here. Okay, so now let's talk about the continue statement too. So let me erase it. So what happens in the continue statement? So here let me write it as continue statement. So a loop is running, then it is continued. Okay. what it would do is skip current iteration, and then it would go to the next iteration. Okay. So unlike break, continue does not stop the loop. It simply skips the current iteration it is working on. Iteration it is working on. Okay. For example, let me write a code for you. So for I in range, let's say 1 comma 11. Okay. So if I equals to 5, then continue. Otherwise, print I. So not yeah. Otherwise, that. Okay. It will push 1, 2, 3, 4. It will skip 5 because it is told there if y equals to 5, continue. Then it will print the rest. Okay. You can see the output. So Python skipped only the number 5. Everything else is continued normally. This is how continue statement works. Okay. So school attendance analogy. Let me give it a example. So suppose your teacher calls the attendance. So students from 1 to 10 are present. Okay. So student 5 is absent. The teacher skips student 5 and then continues calling the remaining students. Okay. It, she doesn't stop on if one student is absent in between. Okay. That's exactly what continue does. So let me write a program for you. Okay, so for this is for printing odd number. Okay. For I in range, let's say 1 comma 21, if I percent 2 equals to 0, then it will continue. Otherwise, print I. Okay. So what would be the output then? So the output is 1, 3, 5, 7, 9. Every odd number. So Python, whenever finds an even number, it skips printing it. Okay. So now let's learn about the statement. Another statement which is the pass statement. Okay. So now let's learn the easiest keyword. So it is the syntax would be, or it is written like if true, then pass. Okay. So what pass does here is pass does nothing. It simply tells Python I will write this code later. Okay. So example, let me give you an example of code using pass. If age equals to sorry, age is taken as input 18. If age is greater than equals to 18, then pass. Print program finished. Okay, start. The output is program finished as it is. Okay, so a real life analogy would be imagine you are writing a to-do list. So you write buy groceries, clean the room, and a blank space and written decide later in bracket. So the blank space acts like a pass. Okay, it keeps your program valid while you decide that what you want to add later. Okay, so simple difference between break, continue, and pass statement would be, let me write it for you. So keyword we'll write here. Words here. What it does. What it does. Okay. So what break keyword does, it stops the loop immediately. Okay. What continue statement does is that it skips only the current iteration. What pass does here is pass does nothing. It's a placeholder for future code. Okay, so I hope you're clear with the difference between these keywords and what are the uses of it, the importance of it, what it does. Okay, let me right let me build a mini project with you all using the concept that we have learned till now. So let's take an input as secret equals to 7 while it is true. True, we will guess the number. Guess equals to int input. Ask the user to guess the number. Number now it will if GUESS equals to SECRET, guess equals to secret, then print CRET. Correct. U GUESSED. Yes. It. Okay. Now we will break it. It is not, so then it will print I again. Okay, as simple as that. So now so the game continues until the correct number is guessed. Okay, so game will continue. 5, not ugly. Try again, try again. Until I enter 7, it will not give, it would give correct, you guessed it right. Okay. The common beginner mistakes that you users tend to do is using break when you actually want to continue. So remember, Break stops everything and continue just skips only one iteration. Okay, so keep it in mind. So, mistake number two is thinking past skips an iteration. No, it literally does nothing. Okay, writing a break or continue outside a loop is also a mistake that people do. This causes an error and uh, this causes an error and that must be inside the loop only. Okay, so now, sorry, now I will give you a practice challenge to pause the video and solve these questions. So some questions are print numbers from 1 to 20 but skip 10. Okay. Also create a password program that keeps asking until the correct password is entered. And also print numbers from 1 to 100 but stop when you reach 50. Okay. So also I will give you some more programs to do in the description. You can check it. Okay. Also, you can also create a simple menu that repeats until the user has chosen exit. Okay. So, excellent work. Today you learned three very important loop control statements, which are break, continue, and pass. So, these keywords are widely used in real world applications such as login systems, games, menus, and automation scripts. So, in the next session, we will combine everything we have learned about loops by building practical projects like menu driven calculators, quiz games, and number guessing games. So, keep practicing today's example, experiment with different conditions, and I will see you in next session. Till then, happy coding. Thank you. So, hello everyone. Welcome back to our Python programming course. Over the last few sessions of our programming course, we have learned almost about loops. Everything about loops we have learned. We have learned for loops, while loops, nested loops, break condition, continue condition, and the pass condition. So today, what we are going to do is combine all of these concepts and build real world programs. So these projects are very similar to the questions that you will file in college practical exams, coding tests, and beginner interviews too. So instead of memorizing syntax, today you will learn how to think like a pro programmer. Okay, so now let's begin with our first project, which is a number guessing game. Okay, so let me open my compiler. Imagine your friend thinks of a secret number. Your job is to keep guessing it until you get it right. That's a perfect use case for a while loop. Okay, so now secret takes secret as an input. Secret equals to, let's say the secret number is 15. So true, while true, guess equals to secret. Print correct, then you guess the number. Stop, then you will break. Add a break here, and then add a if. Sorry, sorry. I have not taken the guess as input only. My bad. Guess equals to int input. I thought I have taken the guess the number as input. Guess the number. Then it will be an if condition. Okay. If then add break. L if guess is less than equal, then print true. Else you can print as too high. It's okay. Now let me explain it to you. So this loop here continues forever. Break stops it when the answer is correct, and elif gives the hint to the user. So let's run this. Sorry, what happened here? While true, what is the wrong hint? So while true. Oh, sorry, I've taken while in. Yeah. So let me guess some number. It will give me too high, so they will take something less than too high, still too high, 20. Too high. I take 10. It's too low. 15. Yes, I've guessed the correct number. So this can be a game sort of thing. Okay. So I have already told that the loop continues forever. Break stops it when the answer is not correct. When the answer is correct, sorry, and else if gives hints to the user to get to the output. Okay. So think of playing guess the number with the friend. So they don't tell you the answer, simply they say higher or lower or correct. Okay. That's exactly what our program is doing here. So next project will be a menu driven calculator. Say like Most applications repeatedly display a menu until the user chooses to exit. Okay, so let's create something like that. So we'll start with while true and let me make it uh, beautiful for display. So it would look good in display. Okay, like this. Menu. Now we'll print first choice as let's say addition. Then we will print uh, second choice as let's say subtraction. Then we would print third. Okay, our choices here are choice equals to int input and type here. It is asking me to enter my choice here. So let's check the conditions. If choice equals to let's say 1, then A would be equals to int input and here first number. Okay, let me get it. First number. Add a space so it looks good. Now we'll shift to B. B equals to int input. There would be second. Okay. Now I will print answer. Answer equals to then I'll simply do the calculation here. A plus B. Okay, so now we use the elif part here. Now we will print here the display that we want to display as let's say thank you. Uh, thank, thank you with exclamation mark, and then we'll apply a break here, and we'll end it by an else statement. Should display the message as invalid choice. Okay, I hope we are clear with it. Uh, let's run this code. So enter my choice. If I add choice as 1, It will ask me to add my first number, second number, third number, answer with adding. So I've taken second number of this. It will be staying it like that. So let me stop it and then edit the code. Here I would like to add a small u. So now it's done. I'll run it and then add my charges too and want to subtract. So first charge will be 99, second charge will be 69. It will give me an answer. Oh, sorry, I have not done doing what will happen. Oh, I've written here 3, that's why it's not working. Okay, sorry. Okay, now it would work, I guess. Think I made it. Oh, yes, I have made a mistake there. Sorry, sir. I need to write the code in. I have not written the elif part. I forgot to write the subtraction part here. So I would add it. Elif choice. Okay, so see, these are some mistakes that I do. We, we all can do mistakes here. Okay, so we just need to keep it in mind. Very interesting and we would take input as first number. B equals to G and good. That's print. Right. Answer. Answer equals to answer equals to doing subtraction with a minus. Now it will work perfectly fine, I guess. Let's do the two, then it will ask me the first number, the second number, it will give you an if I write 3 here, then it will give thank you, and it is. And if we write any other thing instead of 1, 2, 3, then it will give me an invalid charge. Okay. So if every ATM works like this, it keeps showing options until you exit. Okay. So I hope you are clear with it. Now I will stop this. Okay, and write another programs. And I will make you more clear with this with one more project. So that would be a let's say a student mark students marks analyze it. Okay, so let me take student number of students as input. So student and let's do int input. How many students? Okay, how many students will equals to 0 for I in range, let's say student int root marks will plus equals to n arithmetic equals to um, average equals to comma average. Okay. So now, oh, sorry, if I write it 55, then it will ask me the 55 students. It's not possible to enter. That's the first 79, second 21, and third 20. So total marks is 193 and the average marks is 54. Okay. So this is how, so instead of asking for marks one by one manually, Python repeats the input process automatically. Okay. So a real life analogy would be a teacher calculating the average marks of an entire class. So instead of adding everything, let's say manually, Python performs the repetitive work instead. So you can also perform many projects like this, projects like this to help you understand me. So I would do some for you. Let's say password attempt limit. We will do a broad program on this. So let me remove this. Now let's take correct password as input. Python 123 is the password. So temp is equals to 1. Already take first attempt as input. So attempt is equal to 1 while attempt So we'll give, let's say, three attempts to. Okay, while attempt is less than or equals to 3, password equals to input, input, enter password. Okay, so now we'll check the condition if password is equals to, let's say, correct, then it would print as login successful. Otherwise, it will break. Else, print password. Print plus equals to 1 if attempt is greater than 3. So it will print account. Let me print A as capital account half as display in display. Let me run this. It is asking a password, so I will write anything. Wrong password entered, again wrong password entered, and again wrong password. So the account got locked. Okay, so I hope you are clear with it. So this is similar to Gmail's ATM banking app. So they don't allow you unlimited attempts. Okay, or else they could guess your password in unlimited attempts if they get. Okay. So it's for user safety only. So I hope you are clear with it. So we've made a limited loop using while loop 2. Okay. So we can also make multiplication tables. Let me show you an example of one. Let's start with for range 1 to 11. Okay. Sorry, I've written. So let's print slash n table of comma I. Okay, so we'll say use for j in range 1 comma 11 print comma a multiplication sign. Let's use cross x only. Good. Then we'll use the j part then we'll use an equals to sign. Then we'll perform the calculation as I into j here. Okay. And now, yes, we are done. Print it. It's giving me whole table for 1, 2, 3, 4, 5 until 10. Okay. So the outer loop changes the table and inner loop prints each multiplication. Imagine a teacher writing all multiplication tables on the board. So instead of writing each one manually, Python generates them instantly. Okay. So this was it. So we can also create a project on even and odd counter too. So let me help you with it. So let's take even and odd as 0. We can count it. So for I in range from 21, if I percent 2 equals to 0, even plus equals to 1, else it's not even, then it would be odd only. Plus equals to 1. Okay, now it's done. We just needed a sim check simple even statement. If it is even or not, and if it is not even, then it would automatically be odd, na? It's just common thing. Odd number equals to, so even number equals to even numbers, and then for when numbers would be equals to, and then the odd count. Okay, so when we run this between 1 to 20, there are 10 odd numbers and 10 even numbers. If we check between another condition is 55, and it will give me as 27, even 27 odd numbers. Okay, Python checks every number. If it is divisible by 2, then it increases the even counter. Otherwise, it increases the odd counter. Okay. So a mini challenge for you all. So pause this video and create a program that takes, let's say, 5 numbers from the user, finds the largest number and then prints it. Okay. So let me solve it for you only, and I will give you homework for them. Next question will be homework. Largest equals to 0. So for I in range 5, num equals to int input and ask to enter number. Okay, so here if num is less than the largest number, then largest would be the number itself. Okay, it's a simple logic. I think largest equals to the largest number. Okay. Mhm. This version of the code is assumed that the entered numbers are non-negative only. So we'll learn if what happens if we enter non-negative numbers. We learn more robust approach that also works correctly if all numbers are negative. Not in this session. We will learn it later on. Okay. So if we run this code and enter the numbers 55, 66, 22, 1, 2, 3, 9. Sorry, it is not written any. Oh, sorry, I have not written any largest, so it is not. So I do the code again. So enter number 55, 38, 56, 99, 22. It will get the largest as 99. So homework for you all is to build programs like simple ATM menu, which will show balance, deposit, withdrawal, and exit. Also, quiz game which asks questions and calculates the scores, gives average. Okay. Student result system we have already done. So congratulations. Today we built several real world programs using everything we have learned about loops. Okay, so we created a number guessing game, a menu driven calculator, a marks analyzer, a password attempt limiter, multiplication table generator, and even odd counter too. These projects show how loops are used in everyday software, from let's say banking applications to games and educational tools. In our next session, we will begin a completely new topic, which is strings. You will learn how Python stores and manipulates text, okay, and how to access individual characters, slice strings, and use powerful built-in string methods. Until then, practice today's projects. Try modifying them with your own ideas too, and keep coding. I will see you in the next session. Happy coding. Thank you.